Have you ever found yourself pondering about how our Earth came into existence? Our story begins nearly 13.8 billion years ago with the Big Bang. The Big Bang, a theory widely accepted in the scientific community, suggests an explosive moment of singularity. This colossal outburst resulted in the creation of our universe, an event that brought about time, space, and matter. Imagine an explosion so monumental, it breathed life into an endless expanse of nothingness. In the newborn universe's extreme heat, matter and antimatter were formed. These two opposing forces annihilated each other on contact, leaving behind pure energy. But for reasons still not fully understood, there was a tiny bit more matter than antimatter. This leftover matter would eventually coalesce to form everything we know in our universe today, from the smallest microbes to the largest galaxies. As the universe expanded and cooled, atoms began to form, clumping together to create the first galaxies. These galaxies, cosmic kindergartens, gave birth to the first stars. These stars were massive, burning hot and fast, living and dying in the blink of a cosmic eye. Yet, it's in their dramatic deaths that these stars gifted the universe with an essential legacy. As they collapsed under their own gravity, these stars exploded as supernovae, spewing out an array of heavier elements. Elements like carbon, oxygen, and iron, the building blocks of planets and life itself. The universe continued to expand and galaxies grew, hosting countless stars. Each star, a potential crucible for the creation of new worlds. These elements, created by the first generation of stars, are the raw materials from which everything around us, including ourselves, are made. So you see, we are all made of star stuff, our very atoms forged in the heart of dying stars, billions of years ago. In this vast cosmic theater, our home planet was yet to make its grand entrance. Fast forward to 4.6 billion years ago, in a corner of the Milky Way galaxy, a stellar nursery was about to give birth to a star we now call Sun. Picture a cosmic cloud, a nebula, brimming with gas and dust. This nebula, much like a cosmic womb, is pregnant with the potential for stellar life. Under the relentless pull of its own gravity, the nebula begins to collapse. The material within it starts to clump together, forming a dense, hot core. This core, or protostar, is the embryonic stage of a star, and in our story, this is the very beginning of our sun. As the protostar continues to grow, it gathers more and more material from the surrounding nebula. This process, known as accretion, fuels the protostar's growth, increasing its temperature and pressure until nuclear fusion ignites at its core. With this, the protostar sheds its cosmic cocoon and emerges as a full-fledged star, radiating light and heat into the universe. This is the birth of our sun. But what of the rest of the nebula? The remaining gas and dust don't simply disappear. Instead, they form a flat spinning disk around the newborn sun. This is the solar nebula, the birthplace of planets, asteroids, and comets. The material within this disk begins to collide and stick together, forming larger and larger clumps. These clumps, or planetesimals, are the building blocks of planets. And so, in this remote corner of the Milky Way, the stage was set. The sun was shining, its solar nebula spinning, and the planetesimals were starting to stick together. The elements were in place for the creation of something truly remarkable, something that would one day foster life as we know it. With the stage set, the elements were in place for the creation of the Earth. In this swirling disk of gas and dust, the Earth began its formation. Picture a cosmic dance, as particles of dust and gas pirouetted around one another in the vast expanse of the early solar system. Drawn together by the unseen hand of gravity, these particles began a process of accretion, sticking together to form larger and larger clumps. These clumps, each one unique and composed of a myriad of different elements, were the building blocks of the planets. We call these building blocks planetesimals, a term derived from the Latin word planetes, meaning wandering star. In this cosmic dance, the planetesimals continued to collide and combine, growing ever larger and more complex. As these planetesimals grew, they began to exert a greater gravitational pull, drawing in even more dust and gas. As a result, they heated up and underwent changes, becoming protoplanets. This was a critical stage in the formation of a planet. These protoplanets were like adolescents, not quite fully grown, but no longer children. They were in a state of flux, constantly changing and evolving. The birth of the Earth was not a gentle process, it was marked by violence and chaos. The protoplanet that would become Earth collided with other protoplanets in a series of cataclysmic events. Each collision contributed more mass, causing the young Earth to grow larger and hotter. The heat caused by these collisions and the decay of radioactive elements caused the young Earth to melt, allowing denser materials to sink towards the center and lighter materials to rise towards the surface. This process, known as differentiation, formed the Earth's core, mantle, and crust. And so, the Earth began to take shape, a unique planet formed from the chaos of the early solar system. It was a planet of contrasts, with a hot, molten core and a cool, rocky crust. But the Earth was still young, and it had a long journey ahead. With the Earth taking shape, there was still much to come in its journey of creation. As the Earth continued to evolve, it faced a period of extreme bombardment. This period, known as the Late Heavy Bombardment, was a time of cosmic chaos and creation. Picture this, a sky ablaze with falling stars, each one an asteroid or comet hurtling towards our young planet. These celestial bodies, remnants from the early solar system, were drawn in by Earth's gravitational pull, resulting in a series of cataclysmic impacts. It might sound like the stuff of science fiction, but this was a very real chapter in Earth's history. The Late Heavy Bombardment occurred around 4 billion years ago, lasting for a whopping several hundred million years. Now, you might be wondering, how could such a violent period be beneficial to Earth? Well, these celestial impacts played a crucial role in shaping our planet as we know it. The asteroids and comets that collided with Earth were not just bringers of destruction, but also carriers of life's building blocks. They delivered water, carbon, and other essential elements, contributing significantly to the development of Earth's atmosphere and oceans. And that's not all. One particular impact is believed to have led to the formation of our moon. According to the giant impact hypothesis, a Mars-sized body named Theia collided with the early Earth, ejecting a vast amount of debris into space. This debris eventually coalesced, forming our moon and forever linking its destiny with ours. So, in a sense, the Late Heavy Bombardment was a time of both destruction and creation. It was a period that tested the resilience of our young planet, reshaping its surface and seeding it with the necessary ingredients for life. It was a time of transformation, a time of change, a time when Earth was carved and sculpted by the celestial forces at play. The Earth had taken form, but its transformation was far from over. Through fire and ice, through chaos and calm, our planet continued its journey, setting the stage for the next chapter in its remarkable story. Finally, with the Earth formed, the stage was set for the emergence of life. Now, this was not an overnight event, but a gradual process, made possible by a series of fortuitous circumstances. Imagine the early Earth, a world in its infancy. The surface was mostly molten, with massive volcanoes spewing out gases like water vapor, carbon dioxide, and ammonia. These gases accumulated and formed a primitive atmosphere, a blanket of sorts, that shielded the planet from the harshness of space. The cooling of the Earth led to the formation of the early oceans. These primordial seas were not like the blue oceans we know today, but rather a hot, murky soup of chemicals. But within this seemingly inhospitable environment, the magic of life was brewing. In this rich chemical broth, atoms and molecules started to interact, forming more complex molecules. Some of these complex molecules had the ability to replicate themselves. We call these molecules, the precursors to life, RNA. The replication of these molecules was the first step towards the development of life. The early atmosphere, lacking oxygen, provided the perfect conditions for these molecules to thrive. Over time, these molecules evolved, becoming more complex and eventually leading to the emergence of the first cellular life forms, known as prokaryotes. These prokaryotes were simple, single-celled organisms, but they had a trick up their sleeves. Some of them developed the ability to use sunlight to convert water and carbon dioxide into food, a process we know as photosynthesis. This process started to fill the atmosphere with oxygen, setting the stage for more complex life forms to evolve. And thus our Earth, a cosmic masterpiece billions of years in the making, was ready to nurture life, leading to us, pondering about our origins in this grand cosmic theater.